Managing complex networks, cloud services, and SD-WAN requires real-time analytics or deep packet inspection techniques that are application-aware and give deep insight into network performance and how it impacts user-perceived quality. Traditionally, we used hardware probes to provide this function. However, in today's software-based networks, we need to integrate or embed analytics directly into the components that make up the network. VQmon is the leading embedded analytics software for real-time voice, video, and data services. It was first introduced in 2001 and has been integrated into over 500 million devices and systems. This video will briefly explain how VQmon works and why it is widely used. Embedded analytics software is designed to be integrated into an existing device or system without consuming significant resources or impacting performance. This is challenging for networking and networked applications, which typically require some level of decoding per packet. It is essential that embedded analytics software has minimal memory usage, minimal CPU usage, is easy to integrate, and is portable across operating systems and processors. VQmon takes as little as 1/1000th of a MIP to monitor a voice over IP call and is available for all common processor families and operating systems. Virtualized network functions and virtual CPE systems implement traditional networking functions as virtualized software elements that can be dynamically deployed. In these environments, real-time analytics software such as VQmon can be either a deployable element or embedded into a virtualized network function. With over 500 million units deployed, VQmon is the industry's leading embedded analytics technology. It has been widely licensed for integration into routers, session border controllers, SD-WAN systems, gateways, IP phones, soft phones, test equipment, chipsets, and many other platforms. VQmon provides detailed performance metrics, including quality of experience scores, for voice over IP, video conferencing, video streaming and data, and supports virtually all voice, audio, and video codecs and media protocols. VQmon delivers reliable and accurate metrics due to its unique perceptual quality model, which understands the impact of time-varying and transient problems on user-perceived quality. This model has been deployed in the field for 20 years and has proven to give more accurate and stable QoE scores than other approaches. In today's networks, media traffic is commonly encrypted for security and privacy. VQmon can analyze many types of encrypted media without decryption, including secure video conferencing, encrypted video streaming, and premium IPTV channels. VQmon is a high-performance technology that processes up to 4 million packets per second per CPU core while retaining a small memory footprint. It is easy to integrate and has been ported to Linux, Android, iOS, Windows, and other operating systems. It runs on all the common processor families and supports multi-threaded operation. VQmon analyzes incoming packets as data before classifying them as voice, audio, text, or video. For each service type, for example, video, packets are associated with a session and analyzed using algorithms specialized for that service. Metrics associated with a session can be read at any time during the session and when the session terminates. VQmon groups incoming packet flows by VLAN and then by IP flow. It tracks and analyzes UDP and TCP flows independently and reports a comprehensive set of per-flow performance metrics. It identifies ICMP errors, DNS lookup failures, and other problems. It also identifies flows that originate from common social media or search sites and reports the traffic level associated with each site. For voice or audio over IP, VQmon automatically detects the type of codec being used and analyzes each media stream in real time. It uses a playout buffer emulator to determine if later early packets would be discarded and then applies a multi-state Markov model to learn the distribution of lost and discarded packets. The need for this more sophisticated approach to voice and audio analytics is easy to understand. Voice over IP breaks speech into small segments and sends each segment in an IP packet. These packets can get lost on their way to the receiver. If isolated voice packets are lost, then small sections of speech will be missing. The receiver can use packet loss concealment techniques to replace these missing sections. If losses are isolated, this replacement is very effective and the loss in speech quality is minor. However, if consecutive packets are lost, then a larger section of speech will be missing. This means that the packet loss concealment algorithm is not able to accurately replace the missing speech, leading to distortion. Packet loss often occurs in periods of high loss due to short-term congestion in the IP network. This results in intermittent periods of degraded performance. VQmon's multi-state Markov model identifies isolated losses, consecutive losses and sparse bursts of loss, providing a highly accurate model of what happened during a call. VQmon uses this detailed distribution of lost and discarded packets together with a codec model to compute Moser QoE scores. Telchemy's perceptual quality model understands the way that people react to time-varying quality, which makes the resulting quality of experience scores more accurate and dependable. VQmon can analyze video conferencing, streaming video and IPTV services, even when encrypted. By grouping incoming packets into video frames, emulating the decoder's video playout buffer, and modeling the propagation of video frame errors, VQmon is able to estimate the perceived quality of the decoded video. VQmon provides an API that can be used to retrieve metrics for an active caller session at any time. Metrics are available for the interval since metrics were last read, and for the entire session. The most well-known reference for measuring quality of experience is the mean opinion score, or MOS score. Traditionally, this is calculated using a subjective test with a panel of human listeners or viewers. VQmon can accurately estimate mean opinion scores for live voice over IP and video streams at high speed. VQmon has been extensively tested against subjective test databases for a wide range of speech, audio and video codecs, and against full reference objective test tools. Each new release of VQmon is regression tested using Telchemy's database containing thousands of real-world packet captures. In addition, VQmon is continually subjected to advanced fuzzing tests to ensure robustness under all conditions. VQmon is easy to integrate, provides world-class analytics for voice over IP, video conferencing, video streaming and data, is able to analyze encrypted media streams, and has a 20-year track record with a large installed base. Its small code footprint and high-speed, high-capacity packet processing make VQmon ideal for integration into network equipment, software components and devices. To learn more, contact Telchemy today.